Welcome to Container Bytes. In the last video, we looked at the Ray operator add-on for GKE. We created a simple Ray cluster and sent a job to it using the Python SDK.
In this video, we're actually going to cover RayJob in two separate facets and how you can deploy it, whether ephemeral or a stateful type of cluster. So here we have RayJob and RayJob. One just happens to have a space in between. The one on the left without the space is a Kubernetes resource definition, whereas the one on the right is a packaged application of a RayJob. So when we dig a little bit deeper, we have our Kubernetes resource definition on the left, which is actually an end-to-end packaging of both the RayJob and the submission of the job itself.
There are two different experiences with Ray clusters running Ray jobs. Let's take a look at persistent clusters first. Imagine you have a platform team that has already set up a Kubernetes cluster with the Ray operator on it, in addition to one or more Ray clusters that are persistent, long-lived deployments on that Kubernetes cluster. You, as an ML engineer, send jobs directly to those already existing persistent Ray clusters. You have the advantage of sharing those existing resources with other researchers, and you also get all those logs and metrics from your historical runs, all available within the Ray dashboard.
Here we have an ephemeral cluster where a single RayJob submission also creates a Ray cluster inside. These are siloed from a Ray perspective, and from here, each resource, such as the Ray dashboard, would only be available during that job's lifetime. Not only are these clusters short-lived, they share resources amongst only themselves. Essentially, there is no sharing. Sharing is actually happening behind the scenes from a Kubernetes perspective. Each of these jobs, in case what we see, A, B, and C, are all isolated from one another as from a Ray standpoint. Another advantage of having isolated Ray clusters are from a security perspective, where each job is isolated and they are not able to see one another.
So let's get started by creating a Ray cluster in our Kubernetes cluster. This is going to be a persistent cluster that we're going to create by saying kubectl apply. And we can see that our containers are being created on the cluster now. And we have our pods ready. Let's take a look at our cluster. We can say kubectl get Ray cluster to check the status of our persistent Ray cluster. Let's go ahead and send over a job. So here we have the Ray job that we're going to be submitting to our Ray cluster. You'll see that it has a name under metadata and then under spec, the actual command that runs, which in this case just prints cluster resources. Just like node selectors inside Kubernetes YAML, you'll notice a cluster selector field that has a key value pair where you can specify existing persistent Ray clusters. And you'll notice we're specifying the one that exists in our Kubernetes cluster right now. So let's go ahead and apply this RayJob using kubectl apply. Let's take a look at the status of this job. As we can see, the job is now pending and the job's complete. Now we can take a look at the logs using kubectl logs. Now, since this job was submitted to a persistent Ray cluster, we can take a look at the Ray dashboard to look at the logs and metrics of the jobs on this cluster. We can do that by port forwarding the service fronting the Ray dashboard. And then we can head to jobs. And here we can see the logs and metrics for our job.
As you noted previously, a cluster had to have been spun up, as well as a selector. In this case, we are actually specifying all the resources necessary for this particular job. If we start out with the name ephemeral, in this particular case, we could follow this example. And if we scroll down, we can see that the cluster specifications are being defined. The amount of resources required for the head cluster, as well as the worker group. This job is very similar in a sense from an entry point perspective. We're performing the same function as the previous example. So now we'll run kubectl apply of our ephemeral job. Once the job is created, we can see a slight difference. In this particular case, we're actually seeing a cluster that's going to be spun up. You'll note that from our previous one, we had an existing persistent Ray cluster, and now we have an ephemeral Ray cluster that is being spun up based on our job specifications. We'll check on the status of our job. We can see in this particular case that this job is currently initializing. Now our job is in the running state. Once our job is completed, we do see that the status of the job in this particular case is now complete. We are able to see the logs of this particular job very similarly to the persistent cluster. However, because this is an ephemeral cluster, the dashboard would only be available based on a specified period of time. Within the RayJob specification in this particular case, for an ephemeral cluster, we can specify shutdown parameters as well as how long to keep it alive, essentially. Those parameters can be kept alive so that we can see a Ray dashboard if we choose to. However, this is an isolated type of cluster. And as a result, we can use other forms and mechanisms within our provider to be able to see logs.
In this episode, we learned what a RayJob is. We also learned how to use RayJobs on persistent and ephemeral Ray clusters.
Thank you for your time. Join us in our next video where we cover the comparison of our two Ray jobs that we just went through. We'll cover pros and cons, and depending on your type of workload, which may make sense for you.